Okay, so yesterday I promised I would show you an easy way that people can use to test the heat conductivity of certain objects. I'm going to show that to you now. So when you're doing this, I don't really recommend you do this one at home because it involves possibly hot materials. But I'm going to show you how you could do it with like proper supervision and whatnot. So I have here a cup of a pan of water on the stove. It's got the heat turned on. You might see some of the vapor rising up out of it. The temperature of this pot of water is not near boiling. I don't want it to be too hot because I don't want to burn myself here. But the temperature is around 150 degrees Fahrenheit, 53 degrees Fahrenheit. So hot enough to feel the effects of the heat conductivity, but not hot enough to like seriously burn me when I'm doing this. And plus I have hot gloves and stuff to handle stuff as I put them in and out. So we're going to be testing the thermal conductivity of a couple of different objects here. We're going to try it with a metal spoon. We're going to try it with aluminum foil. We're going to try it with a wood pencil. And we're going to try it with a plastic marker. So to do this activity, you want to make sure that when you're putting the materials in, you're not touching the sides of the pot because that could cause melting. We're just going to take the material and we're just going to dip it into the container. So I'm going to dip each object in the hot water for about a minute. You're not going to sit here and watch it stand there for a minute. I'll dip it, then cut it, and then I'll tell you the results when you get back. So the first one we're going to do is this plastic marker. Make a prediction to yourself. Do you think this plastic marker is going to be a good conductor of heat energy or a poor conductor of heat energy? Alright, you've made your predictions. I'm going to dip it for a minute, and I'll cut back. Alright, so our timer's going off, so we're going to pull the marker out of the container and see if plastic was conductive of heat or not. Echo, turn off. Alright, so I'm going to dry each object off before I touch it, just to make sure I'm not touching hot water, but touching the object itself. So drying it off with my thing. Feeling it, it's got a little bit of warmth to it, but definitely not a lot. I can easily touch it without any fear of burning myself. So I would say that plastic, if you predicted it's not a good conductor of heat, you were correct. It's not a very good conductor of heat. Okay, the next one we're going to test is the pencil. So, same process. I'm going to stick it in the container and let it sit for a minute. Alright, so the timer for our pencil just went off, so I'm going to take it out, dry it real quick, and then we'll see if wood's a good conductor of heat. So once again, I'm touching the surface of the pencil. It's a little soggy right here, but it's absolutely not hot at all, so not a good conductor. I'm a little curious about the graphite. Graphite's not very hot either, so basically nothing on this pencil is particularly good at conducting heat. I'm betting if I put it this way, this might conduct heat really well, the eraser band, but I don't want to melt the eraser in accident. Alright, so the next thing we're going to be testing is aluminum foil. So I'm going to stick the tip of the foil in for a minute, and we'll see how well it conducts heat. So make your prediction. Do you think the foil is going to conduct heat better than the plastic and better than the wood, or not? We shall see in a minute. Alright, so our minute's up on the aluminum foil. I'm going to pull it out, and this one I'm going to be careful with. And then I'm going to carefully kind of get close to it. Yeah, so touching this, you can feel that it is definitely much, much hotter than the other two objects we tested so far. So the aluminum foil to the touch is quite hot. It's not burning me because the water's not hot enough to do that, but it's quite hot, and I can definitely tell that it's taken a lot of the heat energy from the water and transferred it into the foil. In fact, if I fill up even higher on it, parts that weren't even touching the water, there's even some heat energy there too, showing that this is a pretty conductive material. Up here, of course, not hot at all because we have the plastic kind of insulating it against the heat, but all the way up to this point, you can feel a good amount of heat in this aluminum foil. So that's why if you're cooking a baked potato, you're going to wrap it in aluminum foil, and you're not going to wrap it in, say, plastic or wood. So aluminum foil is definitely a good conductor of heat. Alright, now the last one we're going to try is the spoon. The spoon here is made of stainless steel, so it's another shiny reflective material. So make your prediction. Do you think this is going to conduct heat well or not? We shall see. Alright, here we go. We'll find out in a minute. Alright, so our spoon has been in the water for a minute. I'm going to pull it out now. I'm going to give it a quick dry, and then we'll see if the spoon conducts heat really well. So, feeling right here, yep, definitely hot to the touch. Oh wow, that's pretty good. It's pretty hot. It's a little bit not as hot as aluminum foil per se, but it's still got a good amount of heat to it. Definitely a better conductor of heat than the pencil and the plastic. Probably not as good as the aluminum though. So I would definitely say that the stainless steel on this spoon is a conductor of heat as well. Okay, so the last thing we're going to test is silicon. We're going to take the silicon tong tips here and stick those into the container and pull them out after a minute and see if they're hot or not, if they conducted heat or not. So make a prediction. The silicon, kind of a rubbery surface here, do you think it's going to be a good conductor or a poor conductor of heat? Alright, so our silicon tongs have been in here for a minute. So we're going to pull them out, dry them off, and see if they conducted heat well or not. So dry them real quick. And just going to touch the outside here. Very, very faint amounts of heat. Hardly any at all. So I would say that this is really good at protecting you from heat, because I'm feeling barely any heat in here at all. Especially as I go up it further, there's absolutely no heat up here in this area, whereas on the spoon and the foil it traveled up pretty high. So I would say these are pretty good at insulating from heat, the silicon grips on this right here. So yeah, just to review, these were not a great conductor. The pencil was definitely a really poor conductor of heat. The plastic was a really poor conductor of heat. The foil was a really good conductor of heat, probably the best one we used today. And then the spoon was also a very good conductor of heat. So if you're trying to cook something, like on a pan or a pot, you will want to use, something metallic, like a foil or a steel pot or pan, aluminum or a steel pot or pan. And if you look in the grocery stores or Target where you can find pots and pans, you'll see they're often made of steel or aluminum. So yeah, those are our best conductors that we use in the kitchen here. I'd love to hear what other materials you would like to test the conductivity of. If it's logical and we can actually pull it off, we might try it. Just remember, it's got to be something that's mostly heat safe, okay? So yeah, that's our little test on how to see if things or materials conduct heat or not.